Okay, so let's solve some molarity questions. The first one is, what is the molarity of a solution that has 333 grams of potassium hydrogen carbonate dissolved in 10 liters of water? So potassium hydrogen carbonate is KHCO3. So the first thing I'll do is calculate the molecular weight, okay, of this one, which is K plus H plus 1 carbon and then 3 oxygen, and that should give me a total of 100.1 grams per mole. Okay, my molarity equation is molarity is equal to moles over liters. Okay, so first I have to find the moles in 333 grams. Okay, so you can do it either in one step, which I'll show you, or do it in two steps. So the first one is finding moles, so 333 grams of KHCO3 times 1 mole divided by 100.1 grams. Okay, so you get the moles, and this should be equal to 3.327 moles. I'm going to go ahead and keep up to 3 decimal places, okay, so that I don't lose any of my accuracy. And then I can go ahead and plug this in my equation, which is molarity is moles over liter. So 3.327 moles, and the liters is 10 liters of water. And that gives me a molarity of 0.333 molar KHCO3. Okay, so that's my final answer. I could have also done it this way, okay, which is molarity is moles. I can calculate that right over here, 333 grams times 1 over 100.1 grams, because this is moles, and divide that by 10.0 liters. Okay, so you can do it this way too. It's up to you. Okay, next question then. Calculate the molarity of 0.552 grams of HCl in 0.592 liters. So again, same thing. I have to find out the mass of hydrogen chloride, HCl. So that's about 1 plus 35.5. So it gives us 36.545 grams per mole. Again, molarity is moles over liter. So I'm going to go ahead and do it the second way that I showed you, which is 0.552 grams times 1 mole over 36.45 grams, and all of that divided by 0.592 liters. Okay, so this is together, and then divide that by the volume. 0.01514 divided by 0.592 liters. 0.0256 molar solution, okay, of HCl. That's what we have. Okay, a little bit turn of a question. How would you prepare a 0.500 liters of 6.68 molar sodium hydroxide solution? So now we're actually supposed to prepare a certain amount of solution with certain molarity. Our molarity is still the same, moles over liter. So we have the moles, the molarity given to us, and we have the volume given to us. So once we figure out the moles, so strategy is to find moles and then grams, okay, of sodium hydroxide. So let's do that. Moles is equal to molarity times liters, which is 6.68 moles over liter times 0.500 liters. That's equal to 3.34 moles. So that's the amount of sodium hydroxide we need, but now we need to convert the moles to grams. Okay, so that's our next step. So 3.34 moles of sodium hydroxide divided by 1 mole sodium hydroxide, and the grams of sodium hydroxide, Na plus 1 oxygen plus 1 hydrogen, is equal to 39.98 grams. That's equal to 133.5, or if you want to round it off, it would be 134 grams of sodium hydroxide. So we need to weigh out 134 grams of sodium hydroxide and then dissolve it in 0.5 liters of water, okay, to get 6.68 molar solution. Another one of the problems: how would you make 10 milliliters of a 0.1 molar KOH solution? So here are the quantities that we need. Again, molarity is moles over liters. To find the moles, we'll do the same thing as in question number 3. So you have to find the moles first, which means moles is equal to molarity times liters. Now there's one additional calculation here, because the volume is given to us in milliliters. We need to convert that into liters. Okay, so molarity is 0.100 moles over liter, and then the liters conversion of 10 milliliters is 0.010 liters. That cancels out, and so we're left with 0.001 moles. So that's the number of moles that we need for the potassium hydroxide solution. And so then we convert the moles into grams, and so 0.001 moles KOH times grams over 1 mole of potassium hydroxide, and the mass of potassium hydroxide, which is 1 potassium plus 1 oxygen plus 1 hydrogen, is 56.096, and the answer is 0.0561 grams, okay, of potassium hydroxide. So it means that we need to dissolve 0.0561 grams of potassium hydroxide in 10 milliliters of water. Okay, that's how you do molarity calculations.